Hi everybody, I'm Amy from MicroBit Educational Foundation.
It's really simple to get started with the BBC MicroBit. You just need a MicroBit, a micro USB cable and a computer. The MicroBit is a piece of hardware, a tiny pocket-sized computer. To make it work, you have to tell it what to do by writing a computer program. Programs are called software. The micro USB cable is used to transfer the program onto the MicroBit. Let's have a look at it. On one side of the MicroBit, you will see 25 LEDs arranged as a square to make a simple display. There are also two input buttons, button A and button B. On the other side, you will see a reset button and a small socket to plug in a battery pack. We explore the processor and other features in further videos in this series. The MicroBit can only do what you tell it to do, so the first thing you need to do is write a program. You can use different programming languages to do this. For example, MakeCode, which works as a block and text editor, or the Python text-based editor. For beginners, MakeCode is a good place to start. We've selected some simple projects to help you. Choose one to get started. The latest version of the MicroBit has some exciting new features. The microphone adds a sound sensor, and the special LED on the front of the MicroBit lights up to show you when this new sound input is measuring sound levels. The speaker lets you add sounds and instant audio output to your projects. On the front of the new MicroBit, its logo is now gold. This new capacitive touch sensor is an input that helps you interact with your MicroBit in even more exciting ways. And now you can turn the new MicroBit off by holding your finger down on the reset button on the back, and you can wake it up by pressing it again.
Many schools up and down the country received MicroBits as part of the Make It Digital project that was run by the BBC in 2016. And the MicroBit Educational Foundation was founded after that in order to basically harness that kind of legacy and take it forward, given all of the successes that we saw in that original project. And so the MicroBit Educational Foundation was born with the support of these organisations that you see on screen here. And our goal as an organisation, as a non-profit organisation I should say, is to inspire every child to create their best digital futures. So ensuring that nobody is left behind with regards to this technology. And given a lot of the stereotypes that are kind of widely reported with regards to technological roles across the world, this is really crucial to our mission to reach 100 million children by 2025, which is our big kind of blue sky kind of aim that we're going for, and Scotland is very much a huge priority for me. We're also working closely with SLIC, the Scottish Library and Information Council, to help train and support the librarians throughout Scotland to be able to deliver webinars, training, and enable access to MicroBits in library services up and down the country. Also doing research with Strathclyde University, and there's loads of brilliant Code Club initiatives happening, one of which is at Hearts Midlothian FC Digital Extra Fund. Of course, we donated loads of MicroBits through them into various programs around the country, and looking to do more of that obviously as we go on. And then also top secret, but this is a project we're going to be working on into next year. We are also working on a project to develop a training program for primary teachers specifically into using the MicroBit. But first, we're focusing on a research project to understand what teachers' needs are in the primary classroom specifically. Heard a little bit in the video about what the BBC MicroBit actually is, but I'll show you now very quickly. It's a pocket-sized computer, so it's super tiny, really tactile, and really user-friendly and robust for young learners. designed to be used by children as young as 7, but we actually have seen some fantastic examples where it's being used by children even younger. But it was designed as part of that BBC project, along with 29 other organisations. So huge amounts of research, huge amounts of testing and knowledge went into the creation and manufacture of this board, and geared at helping pupils to get creative, always encouraging them to ask questions. What else can it do? Where can we go with this? And it starts to kind of really inspire that inquiry, as well as, you know, tapping into those that creativity. What can you make out of it? You can pretty much do anything with it, you know. So that kind of problem solving skills, as well as your computational thinking of your processes in terms of selection variables, all of those things. It incorporates all of that learning as well, while also encouraging that deep creativity and inquiry at its very heart. So we see it working in so many fantastic ways with young learners, and we really want to encourage that as we go on. So and yes, I think in the video, the animation we looked at before, there are 2 versions of the MicroBit. So the original, which is what many of you may already have in school or have maybe used before, is the original MicroBit, which is the exact same size and shape as and weight and everything as the newer one. The newer version, which came out just at the end of last year, is the V2, which has also got a built-in speaker on board on the board, and it also has a microphone so it can send sound, and it has a capacitive touch sensor as well on the front. So that very much works just like your phone screen does, and we're working on new resources to help sort of really bring that to life as well. So and also you've got a notched edge connector on the bottom, which helps crocodile clips attach to it a little bit more easily as well. So we're very excited about that. But what's really important to note about the V2 and the previous iteration of MicroBit is that both versions work seamlessly together. You know, backwards compatibility, we call it. It was a real priority for us when we were developing this new board. We don't. There's at least 5 million microbits out there in the world already, and we want them to continue on to be used in so many creative ways. So if you have access to any microbits at all of any sort, we encourage you to use them and to see what more you can do with them. So that's the V2. And yes, so, you know, why teach with MicroBit at primary, right? Like this is a really, really important thing to kind of get right down to the core of it. Why does it work, and why is it effective? Well, first and foremost, it's so much fun. It's a hands-on experience. It's a physical computing experience. So it's at its very nature, it's incredibly fun and engaging for pupils. To be getting stuck into exploring it, what it can do, what it can do next. And for them and for those learners, the projects that are available are incredibly easy and straightforward to get started with. You don't need any prior experience, either as a learner or as a teacher. You don't need to have done any of this before. It's all geared at and accessible to those with no prior knowledge or experience of this type of technology. And some of the ways in which that works is that the coding interface that we'll take a look at a little later, Microsoft MakeCode, is it's essentially a drag and drop interface, you know, so that it's blocks and they snap together. It's all very user friendly. Everything is color coded. And it's essentially built with that young learner in mind, but it can be incredibly sophisticated at the upper end. So, you know, it's what we like to say an awful lot when we're talking about the MicroBit is that it has a low floor and no ceiling, right? So it's accessible for those very, very beginners first steps. And you can take it right through to powering, you know, all sorts of robots and motors and buggies and all sorts of really cool things like that. If you want, if that's your bag, you know. But we say that all you need to get started with a MicroBit is the device itself. Even that you can use the simulator. You don't even need to physically have devices if you want to get going. So very much like low barrier to entry, and everybody is welcome on the journey. So and then with that. Some of the resources I'll take you through, as Louise mentioned at the beginning, some fun investigations into nature art, outside learning, as well as things like volcanoes and fully resource units. All of that stuff is available and is continuing to be built upon as we go through. And yes, like we said, the computing science is obviously built right into the very heart of all of these materials, but there's so many cross-curricular links into your geographies, your science, your maths, your art, your PE, your dance. You can basically incorporate it anywhere in that vein. So so that just some examples as to why it's useful to be used in primary. So I've already said a lot of this to you, but we'll go into a bit more detail now about the actual resources and the context in which you might use this. So, computing science, or the physical computing sense, in both inside and out of the classroom. So what's really important to note here is that already teachers are all over the world are using the microbit in formal lessons and formal settings, and then also in terms of code clubs and other types of provisions, after school clubs, transition settings, all sorts of things like that. There's a case study on our website which I'll link you to, but it's a really nice example of a program, or a summer school program, that was done to basically support, off the back of the learning that was lost during the pandemic. It was done last summer to support children who were about to transition into secondary school, to be able to catch up on some of the learning they'd missed out on. And MicroBit was at the centre of that, and it was a really, really nice example. And there's a link into that story which you can read. And I recommend you take a look at that. But it's relevant. It's so relevant now, and it'll be relevant through this summer as well. So really nice kind of examples of how it can support that kind of transition as well from primary into secondary. And yes, the kind of curriculum relevance is so crucially important, and I think it's really, really important to note that where the device and teaching with it and using these resources that I'll show you, where they fit in against the benchmarks of the CFE. And I just took a little snapshot of some of the computing science areas here to show you, but in reading through it, to be honest, I struggled to find an area where I couldn't see some relevance to it, and which just speaks to, I think, its nature, So you can have a look here in more detail, and I can share these slides. But ultimately, you're covering your algorithms, you're covering your variables, you're covering your loops, basically everything through all of your steps, right through to through your kind of data logging and things like that as well. So there's all sorts of things that are there to help you kind of feel comfortable that this is kind of meeting those needs for what you need to be teaching. And actually on the site, it's not there at the moment, but I'm working with many with a group of teachers at the moment to help with specific curriculum mapping and tying specific parts of these benchmarks into lessons that are available on the MicroBit website. So that work is ongoing, and we'll be able to put it on there soon. But it shouldn't hopefully stop you from getting stuck in and taking a look at the materials that are already there. So absolutely encourage you to do that. And then yes, just some practical kind of things to note really with regards to consider when you're thinking about teaching with the MicroBit itself. The practical things of numbers of computers that are available, computers or iPads or Chromebooks or whatever it is that you might have access to in the school. Number of those devices and number of microbits. We often say that it's not really essential for every child to have access to their own microbit, particularly for the younger learner. It's often better to kind of incorporate it if you've got a small set, or can group the children into smaller working groups to be able to share their learning, so that one can be maybe using the coding editor, one can be doing an unplugged activity, and one can be actually getting hands-on with the device, and then they rotate. Or as a carousel activity where you've got, the whole class is working their way around and going through that experience where you're doing some of the hands-on stuff and then you move through. There's lots of different ways to incorporate it without needing everybody to be doing the same kind of hands-on explorations at the same time. And also, just some common kind of practices around layout of the classroom and having enough time to take in the materials and all your battery packs and things like that. All that stuff, obviously, we're well aware it takes time, and just ensuring you've got enough time to cover. Something we also recommend to do is if you're starting to introduce the device into the classroom, it's always a good idea to focus on an unplugged activity first, or go one further and use the MicroBit simulator before maybe even getting the devices out of the boxes and onto the tables. It's all of those sorts of things that can just, help to introduce the device and understand what the children are going to be looking at, and then move on into the hands-on experience. But yeah, it's all common sense. You don't need me to tell you really. Yes, so this next section. I'm going to talk to you a little bit about our Make It Code It project. So these are there's a 80 odd of these available on the MicroBit website, ranging from beginner through to advanced, and they are short projects designed to basically help you get started with really quick projects, to use the sensors, to use the inputs on the device, without any kind of prior knowledge or experience of the device, or indeed the coding editor. You can literally be getting started in doing something with this in all of, in a minute or two. All the editors are web-based. The simulator is there for everybody to use. And this is what it looks like. So this is the Make Code editor. You can also code on the MicroBit in Python, which is text-based. And then you can also use it with Scratch. So if anybody's familiar with Scratch, the MicroBit can be used on that as well. The kind of programming paradigm is a little bit different because you use the device as an add-on rather than a simulated MicroBit itself. But if you're familiar with Scratch, it's still worth exploring. But Make Code is where I think it really shines. It's a block-based coding editor. It's color-coded and really user-friendly, and for children that have had any experience with Scratch, it's instantly recognizable because the color codes are very similar. It's sort of a very natural progression from the Scratch kind of experience and environment. You have your workspace, and then you drag and drop your coding blocks into position. And it is, you've got your categories in basic, you've got maths, you've got loops, you've got all of these things, and it's really intuitive and user friendly. And that kind of process, it's built to encourage that progression, and also inquiry and independent learning. What if I try this? What does this do? And ultimately was designed with education at its heart. We work tremendously closely with the Make Code team, who are really fantastic partners to us, and they understand our needs with regards to our teachers and people that are using the MicroBit in this context and in this editor. So we have a really great kind of line of communication into how this is being used and what is happening in the classroom today. And given the pace of change with all these things, this is developing all the time, which is tremendously exciting. But yeah, the Make Code editor is a really fantastic place to kind of get started, because you also have the MicroBit simulator in there as well, which means you don't necessarily have to have the physical device on available to you at the time. So this is one of these Make It Code It projects that I mentioned to you. So because we have the sound working at the start, I will play this for you because I think we have a little bit of time to do it. So I'm just going to show you very quickly an example of one of these projects that we have on the site. So as I said, there's 83 of these available, and every single one of them is made available in this format, which basically is, you've got a video on one side on the left which shows you the project in action, what's actually happening and how it works, with a voiceover from my colleague Giles, who is our education content manager. He'll be joining me on one of these sessions in a couple of weeks' time, so make sure to join in for that one. And then on the right-hand side, we have the actual coding editor itself in action. So you've got the finished project, and then you've got the description and explanation of how to actually code the project available to you as well. So really easy to get started with this. You can watch it, you can see what to expect, so you can watch it being coded, and then you can take it on to do that exploration yourself. So I'm going to try play this and see if the sound comes up. So I'll turn the sound up again and just show you this very briefly.
You can use your BBC MicroBit to learn and use a breathing technique that might help you to feel more relaxed if you're worried or stressed. By creating a program to show an animation on the LED display that you can follow with your in and out breath, you can learn how to breathe in a steady, slow rhythm, which many people find calming. Let's open the MakeCode editor and write our code.
Great. So that's just really short example of one of these projects that you can jump into really quickly and get started with. And then the next one will show you how to code that exact project. But there's so many of these available, and really recommend you have a sift through and see what's there. Really simple, from making a smile appear on the LED interface, through to something a bit more advanced that can react to sense, to sound. It can respond to motion and light and all sorts of other things. But yeah, this is just a simple one that we found was very popular through the pandemic in times of stress. So yeah, definitely encourage you to try that out. And all the links to these things will be in the presentation that will be available to you afterwards.
You can use.
And we won't let Jazz has got a lovely broadcast. I encourage you to watch some of these, but they're great. And this is another example, sharing a smile. So this is slightly more advanced, but a really sweet example of which kind of demonstrates how powerful the device itself is. It's a program that actually uses the radio function on the device. So on the back you can see this little antenna, this little wiggly line here. That's the radio function, which means it can talk to another. When the code is on this and another microbit, they can communicate with each other. And this is a really sweet way where you can use one microbit to send a smiley face to your neighbor's microbit. And it's exploring that concept of the radio function and selection as well. So yeah, really recommend you take a look at that. And it's also just a lovely theme around well-being and kindness, and we all need a little bit of that at the moment in testing times. Great. And now on to probably the most exciting part. I think this might be Louise's favorite bit of this presentation is the volcano animation. So this is brilliant. No, this is great. This is a fully resourced unit of work that's available on the MicroBit website. And essentially, what's great about this is that you can use this to cover off an entire unit, which in which you're covering your geography, you're covering your science, you're covering your outdoor learning. Well, hopefully you don't have any volcanoes locally, but you're covering your outdoor learning, as well as your all of your computational thinking and your computing science concepts as well. And the way that this is structured on the website, so what's available is that there are 5 fully resourced lessons. So there's a huge bundle of materials, lesson plans, handouts, worksheets. The whole kit and caboodle is available to download from the website. But what it also enables you to do is there are elements to it where you can be getting hands-on with the technology, but you're also doing lots of other things as well. So you can see this little green face there, the little MicroBit logo. That is to help you help indicate where in the unit you will be expecting to do specific coding activities and getting hands-on with the MicroBit. So this is a great way to kind of illustrate to you, I suppose, how much you're covering that is in a really broad context, and covering off so many really crucial curriculum areas, but you're not actually doing all of the coding all of the time, right? So it's a really great sort of rich unit for that reason. And you can see some of the kind of topics that it's touching on here, and age ranges. And then we reference that it's we've done this across the board in the site. We talk about age ranges, and there is some reference into the English key stages, but mainly we focus on age, just because it's just that bit easier to understand where it's going to fit in and be relevant to you. But yeah, volcano animations, this is so much fun, because what you're doing is you're coding how the microbit looks when it's erupting, and or how a volcano might look when it's erupting. You're kind of simulating that on the LED display as well. This is a great example where you're basically covering your art, you're covering your geography, you're covering your science, computing science, and you're doing your kind of your coding and your explorations on the microbit only for one part of it, right? So where we see our little green face there, but otherwise you're outside, you're exploring, you're logging your data, you're counting your animals, your birds, and then you're bringing all that information, all those explorations back to the classroom, and then you start to do an unplugged activity, which is where you start to explore algorithms, and you're doing this just on paper, you're doing this on the table. No tech, no devices in sight. You might use the whiteboard and put the stuff up there, but ultimately you start to explore and investigate those concepts without going near any of the tech at all. And then when you get into lesson 3, in that unit, you start to explore representations of those explorations that you've been doing in the unit itself. And then you're using the LEDs, like before with the volcanoes, you're creating nature abstractions using the LEDs on the device. So yeah, that's just another example. But as I said, there's 8 units on the site that are fully resourced like this, and then 83 odd projects available to you as well. And then just to show you very quickly, this is what it looks like on the website at microbit.org/lessons. I'll pop all these links in the chat when I'm done. But yeah, this is how it looks to help you sort of tailor to suit your needs and what you're looking to cover. On the left-hand side, you've got your navigation where you've got your kind of taxonomy, which helps you understand the different topics that are covered in the materials. We've highlighted computational thinking in that one, but you can scroll through it and you've got all sorts of things around safety and security. There's a really great cybersecurity unit. There's focuses on design and technology, photography, and then of course your specific technologies, topics and themes around programming, networks, and computer systems and things like that as well. So that's, you can use the material that way and investigate what's there. Then up top also you've got your age ranges just to help you kind of see what's there for your specific class group and student age range. You may have come across this already. This is our global challenge that we call Do Your Bit. So this is a challenge which is an annual competition, and it's designed so that to encourage young people to come up with creative solutions and innovations to solve problems which are associated with the Sustainable Development Goals, or the SDGs, if you're familiar with them. So this challenge is in its 3rd year now, and it's a great way to start to incorporate using technology, but with the kind of guise or theme of social purpose, right? So putting the use of technology into context to help solve problems. This is a tool called MicroBit Classroom. So this is basically a web-based online lesson tool or coding tool that you can use to deliver a MicroBit lesson and a coding lesson, a really straightforward one. You can do that in a web-based tool that you see here, which enables you to share a link with your students, whether you put it up on their whiteboard or whether you're doing it in a remote session or combined. You put up a link and everybody can join at that link, and the classroom name, for example, might be Red Panda Speedboat Trophy, which is a fantastic classroom name. And then you put that in along with your PIN number, and everybody gets logged into the session together. It's all web-based. You're not downloading or installing anything. No data is stored. There's no passwords or accounts or anything. It's really, really straightforward. But it enables you to share starter code with your class. So, you might have your on button A pressed block. So that's one of your inputs. You might have that on the screen, and then you might ask your students, okay, what do you want the MicroBit to do when you press button A? Do you want it to show a heart? Do you want it to show a smiley face? Do you want it to show a turtle? That kind of thing. And it can be a really nice way to start off showing the students that they have that agency, that they can make that choice. But it also enables you to share that code. So you might have something a little bit more complicated or a bit more, you might have something that's a bit more complete. You might be covering debugging, for example, and you might have an issue in the code and be asking the students to find it in the editor. They can all receive that code on their own machine, and then they can have that experience. And then you as the teacher are able to click on each of their names and see the code that they've got on their workspace. So it's really it's a really, really useful tool, and as I said, all web-based, and you can view coding in real time. And then at the end of the lesson, so this is quite important, at the end of the lesson you can download a Word document, which is basically an HTML file, You can store it on your local school storage. We don't have access to any of this. This has nothing to do with any kind of servers that we're using or anything. It's all web-based. You can download it, and then that enables you to use that file and resume the lesson next time. And it's just, we've designed this in this way with feedback from teachers about what things were getting in the way, what things were taking too long, where were the challenges. And a lot of them, you know, this was all built out of that feedback. Just leave you with a couple of kind of final points. If you haven't got access to MicroBit, or you haven't used one yet, or you're interested in it but don't know quite where to get started, definitely recommend you use the MakeCode simulator first to start having a play. All this material is free, and it always will be, and we just want to make sure that teachers have access to the support that they need. So without further ado, that's all for me on the presentation, and thank you.